Parallel function y equals the square root of x. This is a square root function. For square root, x must be greater than or equal to 0. For the table, we get started from 0, 1. Try to get integer values. We will use 4. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Let's plot these 3 points. 0, 0, 1, 1, 4, 2. Then connect these 3 points smoothly. We could see range is from 0 to positive infinity.
From the graph, we could see it's not symmetric about y-axis. It's not symmetric about the origin. So it's neither.
Let's draw a horizontal line. Only one intersection. So this is a one-to-one function. Cannot be approaches negative infinity. When x approaches positive infinity, f of x approaches positive infinity.
From left to right, the graph goes up, which means the function is increasing in the domain.
No decreasing interval. Y equals x to the third power. This is a cubic function. Domain is all real numbers. Let's make a table. 0, -1, -2, 1, 2. -2 to the third power is -8. -1 to the third power is -1. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. Plot these 5 points. Then connect these 5 points smoothly. Range is all real numbers. Since the graph is symmetric about origin, it's an odd function. Let's draw a horizontal line. Only one intersection. So it's a one-to-one function. When x approaches negative infinity, f of x approaches negative infinity. X approaches positive infinity. F of x is approaching positive infinity. From left to right,
the graph goes up.
so the increasing interval is from negative infinity to positive infinity. No decreasing interval. Y equals cubic root of x, cubic root function. Domain is all real numbers. We will use 0, -1, 1. Since we are looking for integer values for y, for x, we will use -8 and +8. So we get cubic root of -8 is -2. Cubic root of -1 is -1. Cubic root of 0 is 0. Cubic root of 1 is 1. Cubic root of 8 is 2. We will plot these 5 points. Then connect these 5 points smoothly. Y equals cubic root of x. You could see range is also all real numbers. Since the graph is symmetric about the origin, it's an odd function. Let's draw a horizontal line. Only one intersection. So this is a one-to-one function. When x approaches negative infinity, f of x approaches negative infinity. X approaches positive infinity. F of x is approaching positive infinity. From left to right,
The graph goes up.
this is an increasing function. Increasing interval is all real numbers. No decreasing interval.
Y equals 1 over x.
This is a rational function. Since 0 cannot be denominator, the domain is x is not equal to 0. We'll use negative 1, negative 2, negative 1/2, 1, 2, 1/2.
Then we can get corresponding y values.
So let's plot these 6 points. Then connect these points smoothly. Then y-axis is a vertical asymptote line. X equals 0. X-axis is a horizontal asymptote line. Range y is not equal to 0. Since the graph is symmetric about origin, it's an odd function. When we draw any horizontal line, we got only one intersection. This is a one-to-one function. X approaches negative infinity. F of x approaches 0. When x approaches positive infinity, f of x approaches 0. From left to right, the graph is going down. So, no increasing interval. Decreasing interval is from negative infinity to 0. Union 0 to positive infinity. Y equals 1 over x squared. This is a reciprocal squared function. Domain 0 cannot be the denominator. X is not equal to 0. We will use negative 1, negative 2, negative 1/2, 1, 2, 1/2 for x.
Then we can get a corresponding y value.
1, 1, 2, 1 over 4. 1/2, 4. Negative 1, 1. Negative 2, positive 1 over 4. Negative 1/2, 4. Then connect these points smoothly. Y-axis is the vertical asymptote line. X equals 0. X-axis is a horizontal asymptote line. You could say range is from 0 to positive infinity. Since the graph is symmetrical about y-axis, it's an even function. When we draw a horizontal line, we got two intersections, so it's not a one-to-one function. When x approaches negative infinity, you could see the graph approaches 0. When x approaches positive infinity, the graph approaches 0. From left to right, when x is less than 0, the graph is going up, which means the function is increasing. When x is greater than 0, the graph is going down, which means the function is decreasing. So decreasing interval is from 0 to positive infinity.